Good evening, guys. Let us do a few more problems on permutations and combinations. In how many ways can a group of 5 men and 2 women be made out of a total of 7 men and 3 women? There are 7 men and 3 women. We need 5 out of this 7 and 2 out of this 3. Right. So this is very easy problem. We had discussed earlier also. Of 7 people, we need 5. What is this? There is the order is not important. This is a combination problem. So 7C5. 7C5, we'll take this and then 2 out of 3 we need. So 3C2. So what is the total? 7C5 into 3C2. Right. Well, these 5 people can be taken independently. These 2 people can be taken independently. So whatever this number of ways into this number of ways. That is the total combination possibility. Right. What is 7C5? 7 factorial by 5 factorial into 7 minus 5 factorial. That is this, right? 7 factorial by 5 factorial into 2 factorial. Similarly, 3 factorial by 2 factorial into 1 factorial. That is this. So if you multiply both of this, you will get 63. So there are 63 ways to choose 5 out of 7 and 2 out of 3. This is an easy problem. Next. In a group of 6 boys and 4 girls, 4 children are to be selected. Right. Total 10 are there and 4 are to be selected. In how many different ways can they be selected? That's such that at least one boy should be there. So this is the trick. If you have to choose 4 out of 10, then it is 10C4 directly. But here the problem is we have to choose at least one boy. So these kind of problems we have to do this way. So what are the various possibilities? Either one boy, 2 boys, 3 boys, or all 4 are boys. Those are the possibilities, right? We have to choose at such that at least one boy is there. All 4 girls is not a possibility. Either one boy and 3 girls, or 2 boys and 2 girls, or 3 boys and 1 girl, or all 4 boys. These are all the 4 possibilities. Now, independently, these things we can solve. In 6 boys, we have to choose one boy and 4 girls. What is the possibility? Like the previous example only. 6C1 into 4C3. Right? 4 girls, we have to choose 3. 3 out of 4. One boy out of 6. Similarly, 2 boys, 2 girls. What is the way? What is the number? 6 boys. Out of 6 boys, we need 2 boys. 6C2. And out of 4 girls, we need 2 into 4C2. So similarly, 6C3 into 4C1 and 6C4. These are the various possibilities. Now, there are here, this one, we have to do sum of all of this. Either this one or this one or this one or this one. This whatever is the possibility plus this possibilities plus this possibilities plus this possibility. That is the final answer, right? So 61 into 4C3, if you do the calculation, you'll get 24, here 90, here 80, here 15, you'll get. So total 209. You can do this calculations, right? 6 NCR, we discussed earlier also. NCR is equal to n factorial by n minus r factorial into r factorial. You can do all of this, right? So this kind of problem, the little trick is we have to define either one boy or 2 boys or 3 boys or 4 boys. Those independently we can do. Similarly, let's look at the next problem. A box contains 2 white balls, 3 black balls, and 4 red balls. Total how many? 4 plus 3 plus 2, 9 balls. In how many balls? In how many ways can 8 balls be drawn? Of these 9, 8 are to be drawn from the box if at least one black ball is to be included in the draw. Right. Same problem, similar problem. So here we are not worried about how many white and red. We are just worried about black. So similarly, in this case also, how many black balls are there? 3 black balls are there, right? So what are the various possibilities? You take one black ball or 2 black balls or all 3 black balls, right? And remaining are others, right? There was a small error. It was 3 balls, not 8 balls, right? So now there are 3 balls, and we have to take 3 balls out of 3 plus 4 plus 2. 3 plus 4, 7 plus 2, 9. So total 9 balls. Of 9 balls, we have to pick 3 balls. So, and at least one black ball has to be there. So what are the various ways? Either we'll pick only one black ball, or 2 black balls, or 3 black balls. Right. Those are the 3 possibilities. So what is remaining? So one black ball and remaining 2 we can pick from 2 plus 4, 6. Right. In this case, if we pick two black balls, remaining one we can pick from remaining 6. Right. Similarly, if we pick all the three black balls, there's nothing available for the other balls, other white and red balls. So one black and two others. What are the number of combinations that are possible? One black is 3C1. Right. And two others. Others are white plus red, 6. In total 6, we have to pick 2, 6C2. Right. One black and two others. The number of possibilities are 3C1 into 6C2. Similarly, two black and one others. Two black is 3C2 and one others is 6C1. Right. Similarly, all three blacks 3C3. 3C3 is basically 1, right? If you have three blacks and you have to pick all three blacks, how many ways? Oh, there is only one way, right? So what is the total number of possibilities? 3C1 into 6C2 plus 3C2 into 6C1 plus 3C3, right? This becomes 45 plus 18 plus 1, 64. You can do these calculations. You know NCR is equal to n factorial by n minus r factorial into r factorial, right? Next one. How many three-digit numbers can be formed from the digits 2, 3, 5, 6, 7, 9, which are divisible by 5 and none of the digits are repeated, right? So the three-digit number it should be, and it has to be divided by 5. What does that mean? Unit digit should always be 5. Unit digit should always be 5. Remaining two digits, how many choices we have? 1, 2, 3, 4, 5. Right, one digit we can have 5 options. One if we remove because 5 is already taken. Remaining are how many? 1, 2, 3, 4, 5. Here you can take 5 options. This one you can take 4 options. Here please note this is a permutation problem, not a combination problem. Because it is about 3-digit numbers, the order is also important. It's not just, we cannot say 5C2. It is not a combination problem, it is a permutation problem. There are two slots. First slot we can fill with 5 numbers, and second slot we can fill with 4 numbers. Right. So 5 into 4, unit digit is always fixed to 20. 20 are the number of digits that can be found with this. Right. Next, out of 7 consonants and 4 vowels, how many words of 3 consonants and 2 vowels can be formed? This is also very easy. 7 consonants. Out of 7 consonants, we have to pick 3 consonants. What is this? 7, 3. So, see here, when we are talking about words, here it's a permutation problem also. Right. First, we have to pick the number of consonants and number of vowels. After that, we have to order them also. Right. Ordering is also a problem here. Right. Of 7 consonants, you have to pick 3 consonants. How many ways? 7, C3. Right. Of 4 vowels, you have to pick 2 vowels. That is how many ways? 4C2. This is still here, it is a combination problem. So, of the 7 plus 4, 11 letters, 3 plus 2, 5 letters with the given condition. How many ways? There are 10 ways of picking 5 letters. Right. With this 5 letters, of which 3 are consonants or 2 are vowels. This is just picking. Right. 210 is just picking. You are not worried about the order. Now we have 5 letters. 5 letters, the combinations to 10 such combinations which have 5 letters. Now, all these 5 letters can be ordered in 5 factorial ways. Right. So we need to worry about this order also, right? Each of these 210 combinations, each of these 210 combination can be ordered in 5 factorial ways. Right. 210 is just a combination of 5 letters. When you have a combination of 5 letters, how many ways you can order that? You can order them in 5 factorial ways. Right, we have such 210 combinations. Each combination can be ordered in 5 factorial ways. Right, so total how many ways then? Total how many words can we form then? 210 into 5 factorial, which is 25, 200. Right, this is also a good problem. Next, find the number of arrangements which can be made out of the letters of the word algebra without altering the relative positions of vowels and consonants. See, this is a very good problem. He is saying we cannot alter the relative positions of vowels and consonants. If towards the right of the vowel there is a consonant, it has to remain a consonant. If towards the left of a consonant, if there is a consonant, it has to remain as a consonant. That is the condition. What basically that means is in algebra, vowel, consonant, consonant, vowel, consonant, consonant, vowel. So this is the structure, right? The structure cannot change. What he is trying to say is A, E, A, these three can get interchanged among themselves. L, G, B, R, these four can interchange among their positions. Then only the overall structure will remain same, right? Relative positions of vowels and consonants, then only they will remain same. Otherwise, if you try to alter that, right? If you try to alter A and L, then the relative position will change, right? So to maintain the relative position, what we have to do? We have to, in the slots of vowels, we have to put only vowels. In the slots of consonants, we have to put only consonants. Very good. Now, how many L, G, B, R? These are four consonants. Four consonants. And how many ways we can order these four consonants? There are four and four slots, four factorial. That is fine. So, but in vowels, A, E, and A, there are three vowels. We can order them in three factorial ways, but the problem is A and A are repeating. Earlier we had discussed whenever there is a repetition, then what is the way? By will the number of things will get reduced. Right? Repetition will reduce the number of permutations. By how much? By whatever is the number of repetitions, right? 1, 2, 3. We have 3. So 3 factorial by 2 factorial. Right? Because A's are 2 times. Right? 3 factorial by 2 factorial. Right. So 4 factorial into 3 factorial by 2 factorial. Earlier we have also discussed because if all three are same, then there is no way of creating another permutation. Only one permutation is possible. Right. If A, B, C are there, then we can do it in three different ways. Three factorial ways. Because first slot we can fill with 3, second slot we can fill with 2, third slot we can fill with 1. But in this case, but if all three are same, there is no way, right? So all three are same, then 3 factorial by 3 factorial will become 1, right? So the more the repetition, our ability to create permutations will diminish, right? If there is more repetition, our number of permutations will go down. If everything is repeated, number of permutations will be exactly 1, right? The more repetitions, the lesser the permutations. So here two A's are getting repeated. So 3 factorial and we have 3 vowels A, E, A. If instead of A it was U, then 3 factorial would have been the answer. But in this case, because A is getting repeated, 3 factorial by 2 factorial. And all consonants we can order in 4 factorial ways. So 4 factorial into 3 factorial by 2 factorial, which is 72. Right. Both orders we can do independently. So here, so look at this. This is another beautiful question. How many numbers less than 10,000 can be made with the 8 digits? 1, 2, 3, 0, 4, 5, 6, 7. There are 8 digits. And how many numbers less than 10,000? Which are the numbers that are less than 10,000? All 4-digit numbers. 10,000 is the first 5-digit number, right? 9999. Till 9999, whatever is the number, is less than 10,000, right? So what does that mean? How many 4-digit numbers we can create with these 8 digits? So in when we talk about 4-digit numbers, then obviously repetition is possible, right? So basically we have 4 slots. We have 4 slots. 2, 3, 4. Right. And for each slot we have 8 numbers. Right. For each slot we have 8 numbers. Right. 1, 2, 3, 0, 4, 5, 6, 7. You can say why 0 is also counted, 0 is also counted, right? All 4 zeros, then it will become 0. 0 is also a number, right? Right. Otherwise also, if first 3 are zeros, then it will give a single digit number. Right. That is still fine. We are not double counting anywhere. Right. So all what each digit has got 8 options. So 8 into 8 into 8 into 8. 8 power 4. 8 power 4, which is how much is this? It is 4096. 4096 numbers are actually possible with these 8 digits which are less than 10,000. Okay. In how many ways can 7 persons form a ring? Form a ring. Right. So ring. So far we have not what discussed about rings. Rings are circular arrangement. So please note there is a difference between circular arrangement and a linear arrangement. Because circular arrangement, the number of options will reduce. Why? Because it's all relative question. In linear question, it is not relative. So for example, let's take a small example of three people, A, B, C. ABC, they want to sit in linear arrangement. What are the various ways? ABC, ACB, A sits first, then BC they will get interchange, then B sits first, AC will get interchange, then C sits first, and AB will get interchange. Right, for A, BC, CB, for B, AC, CA, for C, AB, BA. Right, these are six options. Six permutations are possible. Right, A can say I'm sitting on the left in this case, B in this case, B can say I'm sitting on the extreme left, in this case, I'm sitting on the extreme left sequence A. Right. This is about linear arrangement. But when it comes to circular arrangement, how many possibilities are there? So basically, this is what? This is 3 factorial. 3 factorial is 6, right? This is 3 factorial. 3 factorial is 6. Right. 6 arrangements are possible when 3 people are there, 3 slots are there. Right. 3 linear slots. Sorry. 3 slots. One, two, three. 3 slots. Here 3 people, here 2 people, here 1. 3 into 2 into 1. So that is 6. This is what we are saying. But if it becomes a circle, in this case, the same thing, if you have to put in a circle, there is only one way. There is only two ways. Right? You can say C is on my left side or C is on my right side. So in this case, you will say C is on my left side or C is on my right side. There are the only two possibilities. For C also it's the same thing. A is either on the left side or A is on the right side. B also it's the same thing. C is on the left side or C is on the right side. There are only two possibilities. See, if you can see, if three people have to sit around a circle, right? Only two combinations are possible.